All right, good morning, folks. Happy Monday. We're gonna get started today with a couple announcements. So I'm just gonna share my my Canvas screen so we can take a look at that. Good morning. All right. So this week's announcements rather. I just want to make sure we're all aware of the week 4 schedule. So today we're going to finish 12.5. That is the last section that will be on tomorrow's exam. So you have an exam tomorrow, which will open at 9:30 in the morning, and it will close 9:30 on Wednesday morning. After that, we're going to jump right into chapter 13 and start with parametric equations, so things that have like a t in them. We're going to be working on those for the second half of the week. This is a bit of a busy week for sure. You've got quiz 7 due by 9:30 on Wednesday morning and quiz 8 due by 9:30 on Friday morning. Now, because the quiz 7 content is going to be covered on exam 2, I will post that answer key on Tuesday so that you can check your answers. I do want you to feel supported and feel confident going into exam 2, okay? Exam 2 is going to cover chapter 10 and 12. Please make sure you leave yourself enough time to upload your exam. I know that most of us have been doing a really great job with that, and once in a while some of us are running into some technology issues. So if you could just try and be on checking your email maybe on Wednesday at some point. I'll try and go through and make sure I know whose exams are good, and in case anybody's exams didn't upload right, I will reach out to you and ask you to send that to me via email, okay? Exam 3, I started planning for our 3rd unit and I changed the exam date. It was originally scheduled to be Monday, July 20th. But now exam 3 will be on Tuesday, July 21st. Okay, so we moved the exam by a day and the schedule on Canvas is updated accordingly. Okay, this next unit is going to be a little bit more of a mishmash. It's mostly chapter 13, but then some applications and then an overview into differential equations, which is a whole nother course in and of itself. So it's just a sampling. And then last but not least, if we are interested, I will certainly open up some windows for exam 2 check-ins. Selfishly, I kind of like getting to meet you and like chit chat with you a little bit and talk about how things are going in the class, but also get to know you as people, because at the end of the day, you're people. And I think it's important that we remember that. So if that is an option that folks like, then we can certainly open up some windows for that. I'm trying to figure out the grading schedule, so I'll figure out like when your test is going to be graded by, and then maybe we can roll it out that way. If you weren't able to figure out where to sign up for the check-in meetings, it's in the calendar option, which I don't know what it looks like for you folks, but on my end, I have like this little calendar button to the side, and that is the place where I can click to add like different appointments and things like that. Okay, so we'll give that another go if that's what folks would like, and hopefully we can all learn to be a little bit more savvy with Canvas. All right, are there any questions so far?
Yes, the quiz that we just submitted, when will we get our like graded score?
Some folks have gotten theirs back. I'm still working on it. So my goal is by the end of today to get those quizzes back to you. I know that you have a quiz tomorrow, or the test tomorrow, so I want to get those back to you. Okay.
Okay, thank you.
Are we going to be able to use a calculator on the exam?
This is a no calculator test.
Okay.
Okay. Any other questions, folks? Okay. Well, in that case, let's go ahead and jump back into 12.5. Someone had mentioned to me that there was a little bit of a issue in terms of uploading the 12.5 notes from Thursday. So I fixed that and hopefully everyone is able to access the notes. But if you ever run into issues like that, please do email me and let me know. It's really helpful on my end because I just kind of post things and I'm like, oh, it should work. But sometimes I like click the wrong link or something went wrong on my end or on the Canvas end. And so those emails are definitely helpful to me. Okay. All right, so let's go ahead and get started with all the algebra that is 12.5. All right, so I'm just going to scroll back a little bit so we can kind of jog our memory a little bit about where we were at on Thursday when we last left off. So on Thursday, we talked about, in the second half of class, using these extended forms of equations to figure out, okay, sometimes it's better if we rotate the axis and define it in a different way. And so we went through one example where it was almost easier to do it without rotating the axis, but we used it to kind of learn the process. And then with example 2, we really jumped into what happens when we can't, it's not easily factorable, or I can't complete the square. And the biggest indicator of you can't complete the square is this term right here. The term that has the x and y together means that it's really difficult to complete the square because the x and y terms are together. And so then how do you break them apart? Okay, so this technique kind of gets around that. And the whole goal of this is to get our equation in a form that looks like whatever shape we predict it to be using the discriminant. And at the end, we should not have any more xy terms. We should only have x prime and y prime, and no x prime, y prime together, but like everything is either x prime or everything is either y prime, or it's a constant, okay? And so we went through these steps here. Now, on the exam, I do give you a loose outline of the steps, okay? So for example, I'll have like determine the shape and general form of the conic section using the discriminant b squared minus 4ac. That will be on the exam. So you don't have to write that down if you don't want to. But I do, one thing I want us to know, and maybe this part should go on our cheat sheet, is given our discriminant, what shape does it mean? Okay, so that would be important to get down on your cheat sheet, because I won't have the thing in the pink, but I will have the step. So it's like you do the math and then you have to interpret what that result means, okay? And then in step 2, after we determined that our shape was an ellipse, we figured out how to find out our angle of rotation. And that angle of rotation we called phi. And so we knew that we could find sine and cosine using the unit circle, but I intentionally picked one in the beginning where we had to use these fancy formulas over here, okay? Those formulas will be given to you on the exam. So this whole like step 2 will be there in words and the formulas will be there, okay? And then it was mostly, if we have to find our sine phi and our cosine phi, we use this cotangent 2 phi to help us access that double angle formula so that we could find our sine and cosine of the single angle, okay? After we did that, we wrote our formulas. So we were like, what are we going to plug in for X and what are we going to plug in for Y? And so we did need to know our unit circle values, okay? Now in this case, we didn't need the unit circle because we had our values from above, but I would encourage you to have at least the first quadrant of the unit circle on your cheat sheet because it's a non-calculator exam, so you can't be like, oh, let me just type in sine 0 on the calculator, see what it gives me. You should have that on your cheat sheet, okay? One thing that I did say that let's really practice doing is factor out any greatest common factor before moving on to step 4, just because it prevents us from dealing with a lot of fractions in this messiness of the work that we're going to do. And that way we can just multiply in the fractions at the end instead of working every single step with fractions. And after that, we started, but we didn't get very far to plug all the different things in. Okay, so everywhere we saw an X, we were putting this 3x prime minus 4y prime times 1/5. Everywhere we saw the Y, we were putting in that 1/5 4x prime plus 3y prime. Okay, so we're just making appropriate substitutions. And again, you can write this all out horizontally, that is totally fine. But again, I tend to not have enough room to write sideways here. So when I write it sort of up and down like this, it makes it a little easier for me to keep track of where all the things are, okay? So that being said, let's go ahead and start with the substitutions, see what we get. So with the 41x squared, all we did so far is plug in, keep the 41 and keep the squared, but everywhere we saw the x, we put 1/5 3x prime minus 4y prime squared, okay? And so now what we're gonna do is we're gonna take this square, we're gonna distribute it to the 1/5, and then we need to FOIL this 3x prime minus 4y prime, okay? So I have 41 out in the front, and then 1/5 squared gives me 1/25. So I'm going to bump that 1/25 in with the same fraction as the 41, okay? And then, because this is the first time we're going through it, I have 3x prime minus 4y prime, and I'm going to be squaring it. So I want to, at least the first time, maybe remind myself actively that I need to FOIL it and not just make it 9x prime squared minus 16y prime squared, okay? There's going to be some extra terms in there that I need to take care of. Okay, so we're going to keep this 41 over 25 in the front. And let's see what it FOILs out to be. The outer terms give me, or the first terms rather, give me 9x prime squared. Outer and inner give me the same thing. They give me negative 12x prime y prime, so I really have negative 24x prime y prime. And then the negative 4y prime times the negative 4y prime is plus 16y prime squared. And last but not least, let's go ahead and distribute that 41 over 25. And actually, I'm only going to distribute that 41. I'm not going to distribute the 25. Okay, so I'm going to keep the 1/25 out in the front. And I'm going to distribute the 41 in there. Now, your exams will not have numbers like this big, so don't worry about, oh gosh, I'm going to have to spend so much time multiplying things out. I just wanted to show us kind of examples with messier numbers, okay? So we've got 369x prime squared minus, 41 times 24 gives me 984x prime y prime. And then 41 times 16 gives me 656 y prime squared. Okay. And now we're going to do a similar thing with this one in the purple here. Okay. So again, our goal is to FOIL things, multiply things, see what constants get brought out to the front, okay? Now in this case, I have a negative 24, but I also have this 1/5 and 1/5, so that gives me negative 24 over 25. And then I have to multiply 3x prime minus 4y prime times 4x prime plus 3y prime. And that is going to give me 12x prime squared minus, I have 9x prime y prime minus 16x prime y prime gives me negative 7x prime y prime. And then the negative 4y prime times 3y prime gives me negative 12y prime squared. And now I'm going to do the same thing again where I distribute that negative 24, but not the 1 over 25. Okay, not the 1 over 25. And so that's going to give me 1/25 in the front. I distribute that negative 24. It gives me negative 288x prime squared. And then I get a plus 168x prime y prime. And then 24 times 12 gives me plus 288 y prime squared. All right. One last one to go. I've got this 34 y prime squared. So again, I made those substitutions on Thursday, and now I'm going to go ahead and take this squared, distribute it to the 1 over 5, and also FOIL this binomial. So I'm going to get 34 over 25 in the front. And then when I FOIL out, I'm going to get 16x prime squared plus 24x prime y prime plus 9y prime squared. And that's going to be everything except for distributing that 34. And so just like all the other ones, I'm going to distribute this 34 to all three terms in here, but I'm going to leave the 1 over 25 out. So 1 over 25. And I'm getting some large numbers here, but again, on your exam, the numbers will be much smaller, okay? So 34 times 16 gives me 544 x prime squared. 34 times 24 gives me 816 x prime y prime. And 34 times 9 gives me plus 306 y prime squared. All right. Now I have to look for some like terms, okay? Now I noticed that every single substitution I made gave me a 1 over 25 in the front. So I'm actually going to take the 1 over 25 out of the entire first three terms. And that's going to give me 1 over 25. And then I'm going to start to collect my like term, okay? So I notice there's a 369 x prime squared. There is a negative 288 x prime squared. And there's a 544 x prime squared. And when I combine all of those together, I end up with 625 x prime squared. Now let's look for the x prime y primes. I have a negative 984, a positive 168 and a positive 816, that adds up to 0 x prime y prime. That's a good thing. We should be getting 0 x prime y prime, and that's a really good indicator that you did it correctly, okay? And last but not least, we collect our y prime squared. So 656 plus 288 plus 306 is going to give me plus 1250 y prime squared. Now there was this negative 25 equals 0 part that I didn't write down before, so I'm going to write that down here. Okay. And we're super close to being done. I know this has been a very long problem so far, but we're super close to being done. Now what we're going to do, instead of distributing that 1 over 25, I'm going to multiply the entire equation by 25 so I can get rid of that 1 over 25. That is going to get me 625 x prime squared plus 1250 y prime squared, and then minus 625, because 25 times 25 give me 625, equals 0. I'm going to move that constant to the other side. And last step, I want to divide by that 625 to make the right-hand side equal 1. So this is going to give me x prime squared over 1 plus 2y prime squared over 1 equals 1. And if I want to write it in a more friendly graphing format, then I might want to write it like this: x prime squared over 1 plus y prime squared over 1/2 equals 1. Okay? Now, at the very beginning of this problem, we predicted, based on the discriminant, that this was going to be an ellipse that had been rotated a certain amount of degrees. And here we see we have that same form of the equation. We have an x prime squared, a y prime squared, they're added together, and it equals 1. Okay, so we have an ellipse here. And so our last step is just to say, okay, if we have an ellipse, then these are the things we need to graph. We need to sketch a graph that includes the rotated shape, the coordinates of the vertices, and the angle of rotation. So I don't need you to do the co-vertices and all the other stuff too, and the foci. You don't have to do that, okay? Just need to show me the coordinates of the vertices as well as the angle of rotation. And so here's what that might look like. So I'm going to draw the original XY axis, okay? And then in a different color, I'm going to draw the rotated axes. Okay, so if we were to label these, this is X and this is Y. That we know. But when we label the green ones, this is our X prime and this becomes our Y prime. So we're rotating it in the same direction we count on our unit circle. So we're going counterclockwise. And after we've done that, we can sketch an ellipse. And so I know that I'm going to draw my ellipse so that it is along that X prime, Y prime axis. Okay. And the vertices are the ones that are further away from the center. So in this case, our vertices are going to be at 1, 0 along the x prime axis and negative 1, 0 along the x prime axis. And then the last thing that you need to show me is just the angle between your x and your x prime. That is your angle of rotation. And if we go back up to the beginning, this was not a nice unit circle value, but we could write it as arc sine of, what did we say our sine was? 4/5. We could just leave it like that if it's not a nice unit circle value, okay? Because if you don't have a calculator, you're not going to be able to find that value by hand, or you could, but it would be very labor intensive. So if it's not a nice unit circle value, you can leave your angle of rotation like this. But if it is a nice unit circle value, I do want to see what that value is, okay?
Do you want it in pi radians, or can we do degrees?
So I know that we mostly work with radians. For these questions, I think that the angle of rotation we could do in degrees, because I think that maybe makes a little bit more sense for these questions.
Thank you.
You're welcome.
Wait, so the degree wouldn't be the 45, it would be...
No, I think it ends up being about 53 degrees or something like that.
Okay, never mind. So
Okay.
the 45 degrees was actually the one before we rotated it, pretty much, or...
45 degrees, I think, was example 1. We're on example 2.
Okay, sorry.
Okay. All right. Any other questions on example 2? I know this is like the most thrilling way to start off your Monday morning.
I have one little question. When we were distributing the 1/25,
Yes.
I think I kind of missed how that happened. Or,
Like where it came from?
well, I know where it came from.
Okay.
I'm just confused as to how the 25 is the only number that changed.
Because if you multiply 1/25 times 25, you get 1. Pretty much.
Oh, okay. So if I were to write this out, right? So if I took the entire equation and I multiply by 25.
Oh, okay.
Okay, 25 times 0 is going to stay as a 0.
Yeah.
25 times 25 gives you the 625, but then 25 times 1/25 goes
Yeah.
to 1, which is why those other numbers don't change.
Okay, perfect. Thank you.
Great.
I have a quick question on the phi value.
Yeah.
If we went back to the original triangle that we did, because I know that on the quiz I did this for one of them, and you just wrote down like the inverse of sine of 24/25, and then you completely divide that by 2 and set that equal to phi, would you accept that as an answer? Or do you want us to go back up to our solved?
I mean, I think the order in which you find them is going to make the difference. So if you had like arc sine of that and then you divide it by 2, that would be fine. Yeah, like this is an option, this is an option. You could certainly use any of the inverse trig functions from your triangle and just remember to divide by 2.
Okay, I was just wondering if I need to go back and change it.
No, that's fine.
Okay, thank you.
Yeah. All right. Any other questions?
Yeah, one last one. So on these equations, the xy term is actually what is rotating our graph, and what we're trying to do is see how many degrees we need to rotate it in order to get it back on like an upright looking position. Because I tried example 1 in Desmos, and when I removed the xy term, it looked like it realigned itself with the xy graph like we're normally used to dealing with.
Yes. So the xy term Like, this is the problematic one.
That's actually what rotates our parabolas or ellipses, and
Yeah.
what we try to do is try to reverse rotate it back so that it's aligned with our original XY graph.
Yes.
Okay.
Yeah. You're aligning it so that you can define it using a set of axes that are perpendicular to each other. Because when things are perpendicular, life is easier.
Gotcha.
Numerically, yeah. Yeah, a lot of the work that you might see in like some of the higher math classes when you get to three-dimensional is the idea that things are orthogonal to each other, meaning that like if you think about the corner of a box, how like everything meets at a right angle, that idea actually makes a lot of computations easier. So when things are orthogonal and you define it that way, then you can do a bunch of computations. All right, so it looks like we got one last example here to work through, okay? I wanted to show us one that had an A, B, C, D, E, and F, like all the terms of the equation are there, and a situation where we have some radicals, because I think I just want to talk about like how we might be able to set that up and what to be careful about as you're working through your computations, okay? All right, so step one, we need to determine the shape and the general form of the conic section using our discriminant, okay? So let's lay out what our A and our B and our C are so that we can plug them in to our B squared minus 4AC and figure out which of those three shapes we're gonna have. Okay, so in this case, A is 1 because 1 is the coefficient of x squared. B is 2 root 3 because it is the coefficient of the xy term, and C is 3 because it is the coefficient of the y squared term. And so when we plug those in, we're gonna get 2 root 3 squared minus 4 times 1 times 3. And so when I square this 2 root 3, I'm going to get 2 squared times square root of 3 squared, which is 4 times 3, minus my 4 times 3. And so I can see that I'm going to end up with a 0. Okay. Now, when you get a 0, it is the second case right here.
Parabolic.
And yep, you are going to end up with a parabola, okay? Now what that means then, if we want to think about the form that our equation should have at the end, we should have like an x prime minus h squared equals 4p y prime minus k. So that would be like if we end up with an up and down one, or we might end up with a side to side one, and then that would be our general form, okay? All right. So from there, let's plug our numbers A, B, and C into the cotangent one so that we can see what kind of angle comes out. And this one is going to be a unit circle one. So I just want to walk us through that process, and that's why I left out the other equations, okay? So our cotangent 2 phi equals A minus C over B. That gives us negative 2 over 2 root 3, which I can reduce. And this reduces to negative 1 over root 3. Okay. If you see a question like this on tomorrow's test, this is a good chance to double check, a good place to stop and double check, because sometimes when we're moving too fast, like I know you guys know that root 3 is on the bottom, but sometimes when we're just like working too quickly, the root 3 like gravitates to the numerator just because we cross some things out. But when we reduce, what we end up with on the top is actually a 1, right? 2 and 2 go away, but they leave a 1 behind. So we still have a numerator here of 1. Now, cotangent is important to think about because it's not on our unit circle, like it's not the x coordinate, it's not the y coordinate, but rather it is the x over y on our unit circle, okay? So I want to think about what coordinate for the x and the y can I use so that when I reduce it, it gets to -1 over root 3. And so I look at the unit circle and I notice that if I have a -1/2 and a root 3 over 2, if I were to reduce that, I would get -1 over root 3. And that corresponds to an angle of 120 degrees. Okay. So I think, James, to your point earlier, if you have the angle, you know that 2 phi is 120, you don't need to use the formulas to find out your sine and your cosine, because you know if 2 phi is 120, then phi is going to be 60 degrees. You have your angle of rotation. Okay, this is a good chance. If it is a unit circle value, just take your angle, your 2 phi, cut it in half, and that will give you your phi. Now, while we're here, let's write out if phi equals 60 degrees. That means we know our sine and we know our cosine, and that's going to be useful in step 3 when we plug things into our equation. So the sine of 60 degrees is the y value at 60 degrees. And the cosine of 60 degrees is the x value at 60 degrees. Okay. Are there any questions about figuring out our phi and our 2 phi? Okay.
For the exam, are you gonna make it like the degrees or the x and y on the positive and negative side, or is it gonna be, it could be like random, like on negative and negative x and y?
Our phi has to end up being between 0 and 180.
Okay.
Okay.
And will we be staying in quadrant 1?
Most of the time it ends up being in quadrant 1, but it could extend beyond that. I think in working through this process, I want it to be a refresher for unit circle values, and also to kind of get us used to thinking about like why some of these numbers are nicer, if that makes sense. Okay, so step 3, let's write out our equation. So I know that x equals x prime cosine phi. And I know that y equals minus y prime sine phi. And y equals x prime sine phi plus y prime cosine phi. So let me give you about 45 seconds to a minute to go ahead and write out these equations using our sine and cosine values that we have for phi, okay? And I'm gonna encourage you to also factor out that greatest common factor. So give you a chance to practice plugging those in, and then we'll get started with step 4, which is gonna be pretty long and super fun.
Will the desired rotation of axis formulas be on the exam?
Yes. Yeah, I think the only thing I'm not giving you is like, if you have your discriminant, how do you know what shape it is?
So just that little table.
Yeah. Okay, so we should have something like this for X and for Y. Greatest common factor here.
1/2.
Yeah, it's just 1/2. And so that'll leave us with an X prime minus root 3Y prime. And so even though we still have the root, at least it's not a fraction. And then our Y, same thing, we'll factor out a 1/2. We'll get root 3x prime plus y prime. Okay. All right, so we're going to take these two equations, we're going to substitute them in to our very long equation that we had at the beginning. Okay, so let me write down that equation here for us again, so we'll have it moving forward. Okay, so everywhere we see the x, we're going to replace it with this, and everywhere we see a y, we're going to replace it with that. Okay, so let's go ahead and start substituting all the things in. So x squared. All right, so the x squared is just my 1/2 x prime minus root 3y prime, and I'm going to square it. And so that's going to give me a coefficient of 1/4. And then when I FOIL what I have on the inside, I'm going to get x prime squared minus 2 root 3 x prime y prime. Okay, because I have like minus 1 root 3, and then the inner and outer each make one of those. So together I have minus 2 root 3. And then square root of 3 y prime. So if I have square root of 3 y prime and I square it, what does that give me?
3y prime squared.
Yeah, it gives me 3y prime squared. So plus 3y prime squared. Okay. So even though it has, even though it has the radical, some of these radicals are going to stay like in that middle term, but some of them will go away like that last term. Okay. All right, well, let's do the second term, which is our 2 root 3 xy. And so that's going to give 2 root 3 1/2 x prime minus root 3 y prime times 1/2, and we have root 3 x prime plus y prime. Okay. And so I'm going to take all my coefficients and bring them out to the front. So 2 root 3 divided by 4. Okay. Now you can reduce that if you want. I've already worked through this problem, so I'm not going to reduce it, and I'll tell you why later. But if you reduce it, it's not going to change that much about sort of our simplifying step, okay? And now when we FOIL, we're going to get root 3 x prime squared plus x prime y prime minus 3 x prime y prime is minus 2 x prime y prime. And then my last terms give me negative root 3 y prime squared. All right, our next term is 3y squared. So I have the 3, 1/2 root 3x prime plus y prime squared. So my constant out in the front is going to be 3 because that was already there, and then 3 over 4 because the 1/2 squared gives me a 1/4. And when I square this term that I have right here, I'm going to end up with 3x prime squared plus 2 root 3 x prime y prime plus y prime squared. I'm going to pause for a moment here just to see if there are any questions on the simplifying. I know that I've worked through this problem, and so I didn't want to have talked through that too fast and not given you a chance to ask any questions, okay? Are there any questions so far about where things came from or where things went? Okay. All right, so let's keep going then. Okay, so these 3 terms are probably the lengthiest terms to substitute in because you have to square things, you have to FOIL things, okay? The rest of the equation, this like 8 root 3x, negative 8y, those are actually not that bad to multiply because you're just distributing a number from the front, a constant from the front. And then this 32, we don't need to do anything to. There's no x or y to substitute into, okay? So those first 3 terms are a place where you definitely want to double check all your signs and whatnot. But the last 3, if you do have those in a test question, tend to be pretty straightforward to substitute in, okay? So we've got our 8 root 3x. And that's going to give us 8 root 3, 1/2 x prime minus root 3 y prime. And this is going to give me 4 root 3 x prime minus, let's see, 8 times root 3 is 8 times root 3. That gives me 8 times 3 is 24, and then I have to divide it by 2, so that gives me 12 y prime. I think I did that correctly. Is that what you guys are getting? Okay. All right, then for the negative 8y, we get negative 8 times 1/2 root 3 x prime plus y prime. And this is going to give me negative 4 root 3 x prime minus 4y prime. And then my 32 just gives me a 32. Okay. Any questions about the substitutions that we made for all 6 terms in our equation? Okay. So what I'm going to do now is this. If we take all of this that we have, okay, and earlier I said I'm going to leave the 1/4 out in the front. And the reason why I wanted to do that is because now I'm going to multiply the entire equation by 4. That's going to get rid of my fractions. I'll still have some radicals, but at least I don't have to worry about fractions and radicals, okay? Now, if you don't want to do this, you don't have to do this. If you want to go right for all the fractions and work with it that way, you're more than welcome to do that, okay? I think that I tend to make mistakes that way, so I don't want to exacerbate my mistakes by multiplying or combining all these fractions and then ending up with a mistake somewhere, okay? So if I multiply every term by 4, let's see what happens. What does our equation become, okay? So let's start with the x squared one first. And this is going to give us, actually, this is going to give us x prime minus 2 root 3 x prime y prime plus 3y prime squared. Okay. So without that 1/4 in the front, it already looks a little bit more manageable. If I multiply the second one by 4, then all I'm distributing is this 2 root 3 is going to get distributed to all 3 terms. That's going to give me 6x prime squared minus 4 root 3 x prime y prime minus 6 y prime squared. If I take the third one and I multiply it by 4, the only thing I'm distributing is that 3. And that gives me 9x prime squared plus 6 root 3 x prime y prime plus 3y prime squared. Now, I can't just do it to those 3 and not the other 3, so I have to make sure that all of these get multiplied by 4 as well. So this is going to give me 16 root 3 x prime minus 12 times 4 is 48 y prime. This is going to give me negative 16 root 3 x prime minus 4 times 4 is 16 y prime. And then 32 times 4 is going to give me 128. Okay.
I'm not seeing where you got 16.
4 times 4 gives me 16.
Oh, I was seeing the 8, and I was like, hold on.
Yeah. So the 4 times 4 gives me that 16.
Okay, thank you.
You're welcome. Okay. So let's combine our like terms. Whew, we got a lot here. X prime, 6x prime, oh gosh, x prime squared, sorry, x prime squared, 6x prime squared, 9x prime squared. That gives me a total of 16x prime squared. Okay. Now remember, we hope that all of our x prime, y prime terms cancel out to 0, right? That was the goal of this whole step. So -2 root 3 of them, -4 root 3 gives me -6 root 3, which is perfect because I have a positive 6 root 3 here. So those do in fact go away. All right, how many y prime squares do I have? I have 3 minus 6 plus 3. Those went away too. But that's okay because I knew from the beginning I was looking at a parabola. So if I got to the end and I had an x prime squared and a y prime squared, that's actually a really good hint that something went wrong if it's for a parabola, right? Because for parabolas, only one of them is squared. So if I have an x prime squared, the y prime squareds better go away. And on the flip side, if I have a y prime squared, then the x prime squared should go away when I reduce, okay? All right, what else do we have? We have 16 root 3 x prime and a negative 16 root 3 x prime, so those cancel. I have a negative 48 y prime and a negative 16 y prime. So that's going to give me, what does that give me, 64? So minus 64 y prime. And then don't forget about the constant, your 128. So we've got a plus 128. And all of that equals 0. Okay? Now, because this is a parabola, I want to make sure I know where my vertex is. And so in order to do that, I need to move my y prime and the 128 to the right-hand side. So I'm going to move those to a different side than my x prime squared. So I end up with 16x prime squared equals 64y prime minus 128. Okay. And I'm going to divide everything by 16. So x prime squared equals 64 divided by 16 is 4. So 4 y prime, and then 128 divided by 16 gives you 8. So I get x prime squared equals 4 y prime minus 2 as my equation. Okay. So let me just get that all on one screen for you. It's so crazy to think that something so complicated looking in the beginning with like 6 different terms in the equation, if we just shift our perspective a little bit, ends up being an equation that I think we would consider pretty easy. One where we can see that it's a up and down parabola. What is the distance from the vertex to the focus?
1.
It is 1. How'd you get that?
The 4 in front is equal to 4.
Exactly. That 4, that coefficient equals 4p, right? So even though we're working in a rotated axis, what that number means doesn't change. And so it's actually, this form is way easier than our original form, okay? So now let's finish this off. We are going to sketch a graph, okay? So for a parabola, I would like you to show me the coordinates of the vertex as well as your phi value. And we know from earlier angle rotation was 60 degrees, okay? So I'm gonna go ahead and sketch an XY regular. And then I'm going to sketch the rotated axis. x prime, y prime. I know this angle of rotation is 60 degrees. And then if I'm going to draw my parabola, where is the vertex of this parabola? 0, good, comma 2. So 0, comma 2 on the green axis, not on the regular xy, okay? So 0, comma 2 means my vertex is here, and that I'm going to be opening up like a regular parabola because x squared means I open along the y-axis. And in this case, it's x prime squared, so it's going to open along the y prime axis, okay? Now, just kind of thinking to tomorrow's exam in terms of review, so here's my vertex, my focus would be 1 unit in, and my directrix would be 1 unit on the other side of that, okay? So these last 2 features you do not need if I don't specify, but I just wanted to kind of get us thinking about that exam for tomorrow, like with a basic parabola, know where your focus is, know where your directrix is, okay? So that is it in terms of 12.5. Okay, I know that these questions are kind of long, and so I didn't want to do too many in here because I think once we kind of get that process, it starts to, become very cumbersome, lots and lots of numbers, making sure you distribute things correctly. So hopefully we've highlighted a few techniques that help you feel a little bit more confident about how to prevent those mistakes. But I will be very honest and tell you when I was doing these to prep for the lesson, I definitely made a whole bunch of mistakes. And I was like, just trying to skip too many steps. So I would really encourage you, not because I think you need them, but I know from my experience that I needed them. So if you find that helpful, don't be ashamed. Like, we're all in this together, and just, writing out all those extra steps made it so much easier for me to go back and, like, if I missed a sign, to just fix that sign and then work my way through the problem. Okay. So are there any questions about this last example?
So for graphing it, we use the phi value to tell how far the graph is kind of tilted or rotated.
Exactly.
All right. Cool.
Yeah, so if we were live in the classroom, I would tell everyone to turn their head 60 degrees to the left, and you'd be able to see that parabola facing up and down.
And for the exam, we just need to label the coordinates of the vertex and the phi value, no any of the other stuff, right?
Right. Okay, Broy, I think you caught my mistake way back earlier before I did. Thank you for that. That x prime is supposed to be squared. And Ali, what if in step 2, when you do a minus c, you get a 0? Okay, yeah, excellent. So let me scroll back up because I think example 1 had it where it equals 0. I hope. Okay, so we didn't actually find that, but yes, if you get a, if you do cotangent of 2 phi equals a minus c over b, and you get 0, that means that 2 phi equals 90 degrees, because cotangent is 0 at 90 degrees, which means that phi equals 45 degrees. Okay, so it's actually really nice when your cotangent equals 0. It's almost like a little gift in terms of finding the angle. The one downside to having phi of 45 degrees is your sine is going to have the radical and a fraction, and your cosine is also going to have the radical and the fraction in both terms. Okay. Cool. Any other questions, folks? All right.
So I do have one, and this is
Yeah.
this is from like way before because I think we went over it on Thursday.
Yeah.
So in step 2, right? So let's say you don't have like a nice angle that corresponds to your unit circle.
Yeah.
Whenever you do the half angle formula, those values will always be positive because we're always dealing with like quadrant 1 or 2, correct?
Right.
Okay, I'm just making sure that I'm not gonna not use the negative one and
Yeah.
have because of that.
Yeah.
Okay, thank you.
Great question. All right. Any other questions, folks?
When are you going to put up the solution so we can check it before we finish up our cheat sheets?
I will post them later this evening. Give you guys maybe some time to like try them first, and then I'll post those solutions. Does that sound okay?
Yeah, I just want to make sure I'm not messing up my thought process.
Yeah. No, that's fair. All right. Well, folks, if there are no other questions, I'm going to stop sharing my screen here. And we'll call it an early day because I know that there's a lot of preparation that goes into preparing for an exam and all of that. Okay, so you have the rest of the morning to work on your quiz and all of that fun stuff. All right.